So which one did you decide goes in the middle? C, carbon, exactly. Carbon's farthest to your left, and carbon is pretty typically in the center. So we're gonna do carbon, and then we're just gonna put the other ones around it. Oops, I don't think I needed to go that far out. Oh, I don't know. My grades are up to date, but the web quest is what y'all did on Wednesday. I was here, and then some people didn't finish it, and I told them to hold it until yesterday. So I don't know if you turned that one in, but it's up to date on the. All right, and you could have put O here and F here. That wouldn't matter, okay? And so then how many electrons did we have to work with? 24, right? Because carbon had 4, oxygen had 6, and then the fluorine was 2 times 7. So that gave me 24. So my next step is just to draw a single bond between each one, and you could have done 2 dots instead. So that used 6. So I have 18 left to work with. So my next one is to give electrons to all of my terminal atoms, and I'm hoping I can give them an octet. So we got that one needed 6. This one needed 6, and my other one needed 6. So 6 times 3 is 18. So that used up my electrons. So does everything have an octet? No, carbon doesn't. So now the question is, which one is going to donate 2 electrons to make a double bond? Fluorine or oxygen? Oxygen, right? We said that was one of the ones that could form a double bond. So it's going to donate 2 of its electrons to form that double bond, and I end up with, and then I still have my halogens over here with all of their electrons. And that would be my good structure right there. So on the quiz on Thursday, you're going to have to do 2 covalents and 2 ionics. Ionics are what we're working on today. They're a little bit different, but that's a good example of one. Alrighty, if you will pull out your notes, we're going to fill some things in on that, and then we're going to do like we did yesterday and use some practice. So we are on ionic compounds where the electrons are not shared, they're actually transferred. So that kind of changes some things up a little bit. All right, so ionic compounds are composed of positive and negative ions. And they're combined so that the positive and negative charges are equal. So overall, the compound needs to be neutral. And that's kind of one of the big differences. Like on a covalent compound, I have to give you the formula. But in ionic compounds, you're going to have to figure out the formula. There's only one way that ionic compounds can be formed. So most are crystalline solids. So think of like salt. And in chemistry, salt means any ionic compound. It doesn't just mean sodium chloride, table salt. And that always occurs between the metal and the non-metal. Remember, the metal forms the cation, the positive ion, because it loses electrons. And the non-metal forms your anion, which is your negative ion, because it gains electrons. So they kind of come together like a puzzle. And notice in the crystal lattice that they alternate. So in other words, I have a positive, then I have a negative, then I have a positive. And you'll have to reflect that whenever you draw out your Lewis dot. Opposites attract. Likes repel, so I'm not going to have a bunch of negative things piled up together or a bunch of positive things piled up together. All right. So like we talked about molecules and molecular formulas that had to do with covalent compounds. Whenever we're talking about ionic compounds, we talk about formula units. So the simplest collection of atoms from which an ionic compound can be established, or ionic formula can be established. And then you have a couple of examples, sodium chloride and magnesium oxide. Notice whenever you have ionic compounds, the metal is always first. And that's how they have to be. It always is the metal first and then your non-metal. So when we draw our Lewis dot, they're going to look different because you're no longer sharing electrons, you're actually transferring electrons. So sodium comes from group 1, so it has 1 valence electron. And then chlorine is a halogen and it has 7, so it makes sense that they kind of fit together. The sodium's willing to give up its 1 valence electron, and then it'll fit right in the chlorine. Then whenever you write them out, because they're ions, they have to be in brackets. And their charge is on the outside of the bracket. Notice sodium no longer has any dots because remember Lewis dots just show the valence electron and it's lost its 1 valence electron. Chlorine, or now it's chloride because it's an ion, it has 8 electrons around it because it reflects the 1 that it gained to get octet to become more stable. So these are what you're going to be drawing that your Lewis dots are going to look like for your ionic compounds. So just like with covalent compounds, they're formed because it lowers the potential energy and makes the compound more stable. It's the same thing with ionic compounds. Favors an arrangement where the potential energy is lowered, is minimized. Form a crystal lattice, so ionic compounds are solid at room temperature. It's a crystal, think of little sodium chloride of table salt. They're little small crystals. And then you have alternating positive and negative ions. Lattice energy is kind of like bond energy. The higher the lattice energy, the stronger the bonds were. So there's 2 types of ions that we'll be using through the rest of the year. The first one is monoatomic ion. So it's made up of just 1 element that became an ion. And then polyatomic ion is 2 or more non-metals covalently bound together, acting as 1 ion. And on the back of your green periodic table, you have your ion list, because this is what we'll start using when we start writing formulas and writing names. And at the top, you have your monoatomics. And then at the bottom, you have all your polyatomic ions. So for instance, NH4, this is ammonium. So the nitrogen and the hydrogen are covalently bound together. But as a unit, they've lost 1 electron, so they act as a unit with a +1 charge. All right. We are going to skip to the table and fill up the parts for covalent and ionic. I forgot to do it yesterday for covalent. So we're going to get your rest of your table filled out. It's just a good summary. Yes, ma'am. Sure. They may need a little bit more time. All right, if you'll pull your practice out, we're going to do examples like we did yesterday. All right. All right, so let's just start with a couple of them. If you notice, you're not given the formula. You're just given what two elements we're going to combine. So you have to figure out the formula. So with covalent compounds, there may be more than one way that two elements come together. In ionic compounds, there's only one way they can come together because it has to be neutral overall. So we'll just start with number one. Potassium is group 1. So it has 1 valence electron. So when it gets rid of that valence electron, it becomes a +1 ion. The ions have to be in parentheses with the charge on the outside. Notice it no longer has any dots around it because that it only had 1 valence electron and it lost that. And this type of representation only shows valence electrons. Fluorine is an halogen, so like all the halogens, it has 7. It's very reactive because it's one away from having an octet, so it makes sense that it fits together with the potassium, which will come in and donate its electron to fill up that octet. So it gains 1 electron, so it becomes a -1 ion. And instead of having 7, it now has 8 valence electrons. All right, so ionic compounds have to overall be neutral. My positives have to equal my negatives. So if I look here, I have a +1 and I have a -1. They do equal each other. I have +1 plus a -1 would give me my 0. So that means I only need 1 of each to make my compound neutral. So I'm going to put them together. +1. F is going to be -1. And then for the ionic compounds, you have to be able to write the formula and name them. In this case, I only use 1 potassium and I only use 1 fluorine. So my formula would just be KF. The metal always has to be written first and then the non-metal. And we would not ever write subscripts of 1. They're just assumed. And then to name it, we've named ionic compounds before. The metal ion stays the same. So that's just potassium. And the non-metal ion, the ending changed to "ide." So this becomes fluoride. Don't forget, if you struggle with changing the ending on your negative ions, they're on the back with the ending already changed. And I misspelled fluoride. All right, so that's an easy one. Obviously, they're not all going to be that easy. So let's look at a couple of other things that might happen. So here I have magnesium and iodine coming together. Was that enough? All right, so how many valence electrons does magnesium have? 2, exactly. All right, so it has 2. 1, 2. So when it becomes an ion, it's going to lose those 2. Instead of a +1 charge, what's its charge going to be? +2. Iodine, another halogen, so it's going to be pretty similar to the fluorine. And it gains 1 electron. And it becomes a -1 ion. Is that my door again? Or am I imagining things? Is that my door again? Okay. So we got a +2 and we got a -2. Those are not equal to each other. That would not give me a neutral compound. So now you have to make an adjustment. And you have to think, which one do I need more than one of? So I'll end up having a neutral compound. So do I need more than one of the magnesium ion or more than one of the iodide ion? Iodide ion, right? So my +2 from my magnesium is good, but I need 2 of my -1 ions for it to equal 0. So I just need one of these, but I need 2 of these. That little column right there, I'm never going to ask you that on the quiz or on test. And if it doesn't help you, don't worry about doing it. A lot of y'all can just look over here and see what you need, okay? So now we put it together. We know we're going to need 2 of my iodides and we want them to alternate. So I'm going to start with my iodide. I put my magnesium in the middle. And then I'll put another iodide over here. And then I need to come back and put my dots around these. This is not the only way that it can be drawn. It can be drawn some other ways as long as you don't have the 2 iodides piled up together. So now if I look, I have a -1 and a -1 for a total of -2. So it cancels out with my +2 and it's neutral overall. So what would my formula be? MgI2, exactly. Always goes first, and I had to use 2 of my iodine, so it got a subscript of 2. To name it, magnesium doesn't change. And instead of iodine, this becomes iodide. Kind of sounds a little weird. And that would be your complete ionic compound on that one. All right, why don't y'all give number 4 a try? See if you can come up with the correct one for that, the name and the formula. All righty. On which one of those did we have to have more than one of? The sodium, right? The metal in this case. So we'll work through that. Sodium is group 1, so it becomes a +1 ion. Did I say a different one? Oh.
Yeah, I did.
So on, if you did number 3, you didn't, then they ended up being equal, right? So this one on number 4, we'll just go through it, okay? Oxygen is, I don't know why I'm having, I'll try to make oxygen halogen. All right, so it needs 2. So it becomes a -2. So I got a +1 and a -2, and this time the metal is my +1. So this is the one that I needed 2 of. And just 1. So when I put them together, like I said, since I need more of my sodium, I'm going to start it. And then -2. And +1. And then I would need to put some dots around here. And then what would my formula be? Na2. Oh, I did that last period too. Sorry, y'all. Na2O. And then what would my name be? Sodium oxide. All right. So I'm going to show you one more that is a little bit more difficult, but it's a combination that you kind of see a lot. So it's number 5. And we'll just kind of work through it together. All right, gallium, Ga is in group 13. So how many valence electrons? 3. All right, let me see if I can actually write the right elements this time. So what kind of ion does it become? +3, right? And sulfur is in group 16. So it has 6, 3, 4, 5, 6. So it becomes what charge ion? -2. So yes, ma'am. Because it has 6 valence electrons and it wants 8 to get the octet. So when it gains 2 electrons, it becomes negative. It'll become negative to how many electrons it gains. All right, so +3 and -2, you know, a little bit more difficult. So you kind of, I guess, kind of think of it like, yeah, 6. You're gonna have to try to get 6 on each side. Think of it like your least common denominator. The smallest number both of them would go into would be 6. So how many of my galliums am I gonna need? 2. And of my sulfides, I'm gonna need 3. That way I'll have 3 times 2 is a +2 and 3 times negative. 3 times 2 is a +6. And 3 times -2 is a -6. All right, now I just kind of start arranging them. So I'm just going to start with my, and like I said, this is not the only way to draw these out. I usually grade these myself because there's a lot of different ways you can draw this out. Oops, coming. The only thing that would make it wrong is if you had all your negatives together, all your positives together. Gotta alternate somehow. All right, so that's a +3, and then I'm gonna put a -1 on the other side. And then what else do I need? I need another gallium. And then I need one more sulfide. And then you would have to come back and put your dots around the non-metal. And so that way, if I look at them, I have a +3, and I'm just drawing circles around it. This is not part of, just like yesterday, it's not part of the structure. +3 gives me a total of +6, and then I have -2, -2, -2, so a total of -6. So my positives and negatives cancel out. So what would be my formula here? GA, that's it. Metal always goes first, and then its name would be, GA is galenium. Galenium sulfide, exactly. All right, so which one do y'all like better? Ionic, covalent? Don't have an opinion on it. Ionic, me too. All right, maybe take a couple of minutes to try those other couple on the front. And like I said, tomorrow, I'm just going to give y'all time to work on both of them, ask questions. And that way, before we have the quiz on Thursday, hopefully everybody will be all well prepared for it.